Hello, welcome guys. Welcome to Unacademy, India's largest learning platform. Welcome to the session. I'm Sunil Manjani. Okay, I got a 15 plus years of teaching experience. I mentored thousands of students for GATE ESE and semester exams. I've cracked PSU exams like GATE, Hall, Mahadiscom, and Mahajanko. This is how you can install an academy and use it. Okay, go to Google App Store and Play Store, type in Unacademy. There is a Unacademy learning app. Okay, welcome guys, welcome to Unacademy. Okay, install it. Okay. After that, go to manage goals, select GATE and ESC. Step 4 is select any subscription. Step 5, put the click on get subscription button. Okay, okay. So plus subscription will is cost you 27,225 for 12 months and 39,600 for 24 months. Again, for further discount, you may type in my uh, uh, reference code SSM10. Okay. As far as an academic program is concerned, 12 month is costing 45 to 25, 24 month is costing 66,600. Okay, put in SSM10 for the referral code. Okay. So what is plus subscription? In this, India's best educator teaches you. There is interactive live classes, structured courses, and PDF live tests and quizzes. Okay. What is iconic subscription? All the features of plus course plus personal coach, personalized test analysis. Okay. Study planner and preparatory study material for yourself. Okay. This is the extra features of plus course. These are the extra features of plus course. Okay. So in last class we did some control system. In special class we did some control system. Okay, so in today's class we'll study control system application in MATLAB. Control system application using MATLAB. Okay, control system application in MATLAB. So let us see where were we yesterday. Yesterday what we did was we studied about Laplace transformation, okay, using MATLAB. Laplace transformation using MATLAB, okay. So let us see. Today we'll study about block diagram representation. Block diagram representation. Okay. So we studied about partial fraction expansion, Laplace transform. Okay. So let us see how we can use block diagram reduction in control system. Okay. So first one is series connected block. Connected blocks. Okay. What is the diagram? G1S is equal to N1 divided by D1. This is input. Input is RS. Okay. Next diagram, G2S is equals to numerator 2 divided by denominator 2. This is output. C of S. Okay. So this I can write down as input RS, G of S is equal to N of D. This is C. So what will be the MATLAB expression? N comma D is equal to series N1 comma D1 comma N2 comma N2 comma D2. Okay, comma N2 comma D2. So this is first one. This is series command. Okay, let us move on to second one. Parallel connected blocks, parallel connected blocks. Okay, so here representation is like this. Input, okay, this is G1s, is equals to N1 divided by D1. This is G2s equal to N2 divided by D2. N2 divided by D2. Plus plus. Okay, this is output C of S. This is input R of S. Okay, how it will look like? How it will look like? It will look like this. After reduction, N by D, Cs, this is Rs. Okay, so this is the equivalent form. Now we'll see what is the MATLAB code. Okay, in previous problem there was one more MATLAB code here. It was print sys. Print sys is equal to N comma D. Okay, now MATLAB कोड क्या रहेगा इसमें? पैरेलल कनेक्टेड ब्लॉक में N comma D is equal to parallel N1 comma D1 N2 comma D2. Print sys N comma D. Print sys N comma D. Okay, so this is second one, blocks connected in parallel. Third one, blocks having blocks having feedback path. Okay, so let us see how the blocks look like. Plus minus, this is G1s N1 by D1. This is output feedback G2s equal to N2 divided by D2. This is C of S output. Input is R of S. Okay. Let us see how it can be reduced. It can be reduced in a simple form. GS N by D. Output C of S. Input R of S. What is the MATLAB command for this? Okay. N comma D is equal to feedback n1 comma d1 comma n2 comma d2. Okay, then print sys n comma d. Okay, this is okay. So now we'll see one example, very good example. This is one block, this is other block, one summing point, other summing point, one block, this other. This is input R of S. Okay, this is like this. This is plus, this is also plus. Okay, this is plus, this is transfer function s upon s square plus 2. This is feedback s. This is output. This is output. Output feedback minus. This is output C of S. This is transfer function 1. Transfer function 1 upon S plus 1. This is transfer function 2, S plus 2. This is transfer function 3. This is transfer function 4. In this way you have got one block diagram. Okay, what you need to know is obtain overall transfer function. Okay, and show its whole zero plot, whole zero map. Show its whole 0 m. Okay, so how to write down the program? How to write down the program? We will write down the program. Meanwhile, what we'll do, we'll start the MATLAB application also. So let us start MATLAB application and go in for, okay, this. Let it be starting in background. Okay, so first of all, program is clear all. This is clear all TLC. Okay, see, first of all we'll write down for transfer function. 1. Numerator is how much? N1 is how much? Only one element. D1 is how much? Coefficient of S is 1. This is also 1. So 1, 1. N1 D1. Okay. N1 D1. So I will write display transfer function 1 is, okay, parenthesis n1 comma d1. Okay, now transfer function 2, no numerator, oh sorry, no denominator, only numerator. So let us see, and numerator coefficient of s is 1, this is constant 2. So parenthesis, after that we'll write down n2 is equal to coefficient of s, that is 1 and 2, 1 space 2. Denominator is not there. Denominator is not there. It is s by s plus 2 only. So s plus 2 upon 1 we can do. We can write down upon 1. So denominator, no s terms, so 0, constant term is 1, like this. So display transfer function 2 is, parenthesis what you want, n2 comma d2, What about transfer function 3, n3? Let us see, n3, numerator is 1, denominator is, the s square term is 1, there is no s term, that means 0. So what will be the coefficient of numerator? What will be coefficient of numerator? 1. S term is 1. Constant term is 0. So 1, 0. Okay. For denominator, S square term is 1. S term is 0. Constant term is 2. So 1, 0, 2, like this we will write down. So this is 0, 1. D3 is equal to 1, 0, 2. 1, 0, 2. Then again display transfer function 3 is, okay, like this. Let us write down for transfer function 4. So transfer function 4 is s, which implies s by 1. Here s term is 1, constant term is 0. Here s terms is 0, constant term is 1. So 1, 0, 0, 1, like this. And 4 is equal to 1, 0. D4 is equal to 0, 1. D4 is equal to 0, 1. I will write down display transfer function 4 is, like this. Okay. Okay, then parenthesis. Okay, here we have forgotten one thing. Here we will write down here in this code in between this parenthesis n3 comma d3. Here we will write down parenthesis okay. So this is the system value. Okay. Now see the block diagram. I'm just moving down this block diagram, writing down one block diagram once again. See this block diagram. Transfer function 1 and transfer function 2 are blocks connected in parallel. So I will say transfer function 5, this one. Okay. TF3 and transfer function 4 are connected in parallel, and these are connected in feedback. So transfer function 6 is in feedback. Okay. Now if I have all these values, okay, I have got transfer function 5, okay, and I have got transfer function 6. So this connection will be like this, CS, RS. Now what is the overall connection? Series connection. Overall connection is series connection. So I will say this series connection is transfer function 7. CS, RS. So this is the block diagram reduction. Okay. So transfer function 2, transfer function 2, sorry 5 now. Okay. So what I will get, okay. See here transfer function 1 and transfer function 2 are in series, sorry parallel. So I will say numerator 5 comma denominator 5 is equal to parallel n1 comma d1 n2 comma d2. Okay, so display transfer function 5 is parenthesis n5 comma d. Okay, now let us move on to transfer function 6. n6 minus d, sorry, comma d6 is equal to feedback of what? Transfer function 3, so n3 d3, and transfer function 4, n4 d4. Display Transfer function 6 is parenthesis 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 n6 comma dc n6 comma dc. Let us see next. Okay, this is another code. Okay, this is another code. Let us see next. Now transfer function 5 and transfer function 6 are known. These two are now in series. So I will say n7 comma d7 is equal to series of n5 comma d5 comma n6 comma d of d6. Okay, so next we will write down overall transfer function. Okay, overall transfer function is, then I will write down print this parenthesis sorry parenthesis parenthesis n7 comma d7 n7 comma d7. Let us write last part, that is pole zero map. Okay, so you will write down system1 is equal to transfer function n7 comma d7. Okay, then pz map is equal, sorry, pz map in brackets system1 in bracket system. Okay, so this is quite simple. Okay, we will write the code in a script file. Let us see. Okay, let us see. First of all, clear all, then clc. Okay, n1 is equal to 1. Okay, I will keep on writing this, semicolon. d1 is equal to 1 space 1 semicolon. Okay, so you can write down another format also, but rather we must be careful that it is nicely presented. Transfer function 1 is like this. Then print sys n1 comma d1, n1 comma. This code, remember, is repeated for other transfer functions. So we'll see this is equal to okay. So n2 is equal to n2 is equal to 1 base 2 to d2. This is n2. Okay, d2 equal to 0 space 1, 0 space 1. Transfer function 2 is n2 comma d2 princess. Okay, like then n3 is equal to 1 space 0, d3 is equal to 1 space 0 space 2. Okay, transfer function 3 is n3 princess n3 comma. Okay, control V, n4 is equal to 1 space 0, d4 is equal to 0 space 1. Transfer function 4 is princess n4 comma d4. Okay, that like this you will get the okay. Then the code changes. Okay, n5 comma d5 is equal to n5 comma d5 is equal to parallel okay, parallel n1 comma d1 comma n2 comma d2 bracket. Display transfer function 5 is okay. Print says bracket n5 comma d5. Finish. Okay, then again control C, control V, n6 d6 is equal to feedback n3 d3 n4 d4. Transfer function 6 is parenthesis n6 Ds, control V, n7 D7 equal to series of what? Transfer function 5 and transfer function 6. So 6 n6, sorry, parenthesis n7 d7. Here transfer function 7, or rather you will say overall transfer function is parenthesis 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 n7 d7. Then comes your plot. This one is equal to transfer function of n7 comma d7. Okay, dz max sys 1. So let us save this. Let us save this code in F drive Unacademy exercise BDR1, block diagram reduction, just BDR1. BDR dz map. Okay, so let us see, let us save, let us run this to change the path. So F colon or F drive is Unacademy. Then we move on to exercise. Okay, let us see where is the problem. This is equal to, and then run it. This dot, so I'm going to enter comma. Okay. Save it, then run it. Okay, this is overall transfer function. This is pole zero plot, okay, of overall transfer function. Pole zero plot of overall transfer. Okay, so in this way you can find out block diagram reduction. Block diagram reduction. Okay. Okay, so I will give you one homework for you to solve. Example for this control system is okay. So let us see what is the example. Actually, I want to give some simple example to you. So plus minus, okay. This is 2 upon s plus 4 1 by s s plus 2 . 2 . 2 . 2 . 2 . 2 . 2 . 2 . 2 . 2 . 2 . 2 . 2 . 2 . 2 . 2 . 2 . 2 . 2 . 2 . 2 . 2 . 2 . 2 . 2 . 2 . 2 . 2 . 2 . 2 . 2 . 2 . 2 . 2 . 2 . 2 . 2 . 2 . 2 . 2 . 2 . 2 . 2 . 2 . 2 . 2 . 2 . 2 . 2 . 2 . 2 . 2 . 2 . 2 . 2 . 2 . 2 . 2 . 2 . 2 . 2 . 2 . 2 . 2 . 2 . 2 . 2 . 2 . 2 . 2 . 2 . 2 . 2 . 2 . 2 . 2 . 2 . 2 . 2 . 2 . 2 . 2 . 2 . 2 . 2 . 2 . 2 . 2 . 2 . 2 . 2 . 2 . 2 . 2 . 2 . 2 . 2 1 upon s plus 3. This is cs. This is rs. This is the arrow. This is arrow. Okay. 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 So this here to solve. How you will solve? Okay. How you will solve? Just I will give you a hint. These two forms feedback. Feedback. These two forms parallel path. Okay. And these two will form series path. So you need to determine overall transfer function, also plot pole, also map pole 0. Pole 0 mapping you need to do. Okay. So fine. Okay. So just pause the video when you are seeing this and then solve it. This is all about what? This is all about block diagram reduction today. Block diagram reduction today. Okay. Now we move on to another topic in control system where MATLAB can be helpful. Is time response analysis, or rather simply time response. Time. Let us see. Okay. So any response, any response is equal to transient response plus steady state response. Plus steady state response. Okay. So suppose I have got a signal whose input value is like this. Okay, this is input, and I have got a signal. Because of this, what will be the response? Okay, response will be like this. This is the response. This is time response. Okay, so I will say that this period is nothing but transient period or transient response, and this period is called as steady state response. Steady state. Okay. So in this way you can classify transient response and steady state. Input signals, we will see what are the input signals. This is step function. Step function. This is RT. RT. This is time t. This value is suppose R. So RT is equal to R for t greater than equal to 0. This is 0 for t less than 0. Laplace transform will be Rs is equal to R by S. This is step function. If R is unity, this is unit step function. This will be equal to ut, that is 1 t greater equal to 0 equal to 0 for t less than 0. U of s is equal to 1 by s. U of s is equal to 1 by s. This is first signal. Let us see second signal. T, this is equal to RT. This slope is R. This is ramp function. Ramp function. RT is equal to capital R into T for t greater than equal to 0. Equal to 0 for t less than 0. Laplace transform is 1 by s square. Okay, this is the Laplace. Okay, now see that if R is equal to 1 here, this is called as unit ramp function. Then RT is equal to t for t greater than equal to 0 is equal to 0 for t less than. Rs will be equal to, this will be sorry, R by S square. This will be 1 by S. Okay, let us move to third signal, that is this signal RT. Slope is like this. Okay, this is RT. Slope is RT. This is time t. Then I will say this is the parabolic function. RT is equal to RT square by 2 for t greater than equal to 0 is equals to 0 for t less than 0. What will be Rs? Rs is equal to R by S cube. R equal to 1. Unit parabolic function. RT is equal to t square by 2 for t greater than equal to 0. 0 for t less than 0. This is 1 by s. S, change this. Okay. One upon fourth function is equal to this is RT, this is time t. This is impulse function. That means height tends to infinity, width tends to 0. RT equal to R, 0 less than equal to t less than equal to delta t is equal to 0 for 0 less than t greater than equal to delta t, greater than equal to delta t. Okay. What will be Laplace transform of this? Laplace transform of this is equal to 1, R, constant. Similarly, if R is equal to 1, RT is equal to 1 for 0 less than equal to t less than equal to delta t is equal to 0 for 0 t greater than 0 greater than equal to delta t. What will be RS? That will be equal. In this way, we have defined some function, MATLAB function. Response. Okay. Now we move on to next topic, that is step response using MATLAB. Using MATLAB. Let us see. What is the syntax? Any function s is equal to numerator by denominator. So syntax is step numerator comma denominator. Okay. You can write down time signal also, numerator comma denominator comma time, or you can write down step system. Okay. In this way you can write down the program. Okay. So let us consider one example. GS is equal to s plus 1 upon s plus 2. Okay. Then what you need to do is you have to determine step response. Okay. So what is the program? Let us see the program. Okay. First of all, clear all TLC Okay, see here. This is one more thing is given. See here, one more thing is given. This is a forward path transfer function. You need to determine unity feedback system steps. So there is a difference. Okay. So first of all, what we will do, we will not write the program initially. We will first of all formulate the problem statement. Formulate the problem statement. Okay. Unity feedback system. HS is equal to 1. GS is given. Then it will be like this. RS plus minus, this is CS GS HS. HS is equal to. So if I reduce this, it will give me GS upon 1 plus GS HS. Okay. So let us see what is GS. GS is equal to S plus 1 divided by S upon S plus 2 upon 1 plus S plus 1 upon S into S plus 2 into 1. This is the transfer function. So if I solve this one, okay, I will get S plus 1 upon S square plus 2S divided by S square plus 3S plus S square plus 2S plus S plus 1. So S square plus 2S plus 1S is 3S plus 1 plus 1 divided by S square plus 2S. So these two will get cancelled. Okay, what remains is the overall transfer function. Yes. S plus 1 S square plus 3S plus 1. Okay. Now if you consider this, if you consider first example, our first example, see here, this was our first example. Here feedback system is this. Okay, that is N3 and N4. N3 and N4. So you required the numerator and denominator by using this function. Okay, so using this function. Okay, so let us see that if this is the function, this is the function. If I don't want to solve this, don't want to solve this because I have to write down only MATLAB program. So how it will appear? How it will appear? Let us say this is s plus 1, okay, upon s square plus 2s. Isn't it? I solved, open the bracket only. This is feedback system. This is only 1. So transfer function 1, transfer function 2. Okay, transfer function 1, transfer function 2. Okay, I want to define these in numerator and denominator form. Coefficients, numerator and denominator coefficients. Then how I will define? What will be numerator coefficients? See, coefficient of s is 1, constant term is 1. This is n1 I will say. D1 will be, what it will be? S square plus 2s plus no constant term 1, 2, 0. Okay, this is transfer function 2. So n2 is equal to, see here, this is only 1. I can say that this is 1 by 1. This is 1 by 1. Okay, so I will say 1. D2 denominator is also I will say. Okay, so in this way I can define the numerator and denominator term. So how to write down program? How to write down program? Let us see how to write down the program. Okay, so see, clear all, TLC, N1 is equal to 1, 1, N2 is equal, sorry, D1 is equal to 1, 2, 0. Okay, 1, 2, 0. Okay, N2 is equal to 1, D2 is equal to 1. So I will write down N3 comma D3. It is a feedback system, so I will write down feedback N1 comma D1 comma N2 comma D2. Okay, then print sys N3 comma D3. Okay, then I will write down step response N3 comma D3 grid on. Okay, label it, x label is equal to time, as you know, y label is magnitude, Okay, y label is equal to magnitude. Such a short program because you need to find out only step response. So let us write clear all CLC. Okay, n1 n1 is equal to n1 is equal to 1 comma 1 n dot d1 is equal to 1 space 2 space 0. Okay, n2 is equal to 1, d2 is equal to 1. Okay, d2 is equal to 1. Okay, then n3 comma d3 is equal to d3, or rather I will say feedback n1 comma d1 comma n2 comma d. Okay, this is then parenthesis n3 comma d3. Okay, then I will say step n3 comma d3. Okay, then grade on x label time y label magnitude. Okay, so in this way, this is the simple program I have written down. I will say step response MATLAB 1. Okay, so I will run this. S plus 1 upon s cube plus 3s square plus 3s plus 1. Remember this. S plus 1 upon s square plus 3s plus 1. Let us see the figure. So this is the step response. Okay, in this way you will find out different responses. Now we'll verify this also. We perform one hand calculation. Okay, so this one was hand calculation solved. So this is same as this one, isn't it? S square plus 3s plus 1, like this. So our answer is correct. Okay, so okay, so we'll take one more example. Let us see the example. overall transfer function. Okay, first we need to find out what is step response characteristic. Step response characteristic. What are these? What are these? Okay, these characteristics are nothing but rise time specifications. Okay, then settling time. Okay, then settling minimum time, settling maximum time, overshoot, overshoot, undershoot, peak, peak, and then peak time, peak time. These are the some of the characteristics of step response. How to find this using MATLAB. Okay, so for that we'll consider one example. Overall transfer function is equal to Cs divided by Rs is equal to 10 upon S cube plus 7s square plus 10s plus 10. ये आपका स्टेप रिस्पॉन्स सॉरी ओवरऑल ट्रांसफर फंक्शन. Okay, you have to plot step response and find step response characteristic. Example, isn't it? So this is transfer function. How to write the program? What will be the program for? Let me check. Okay, the program. Okay, here we'll use simple clear all TLC. Okay, numerator is equal to 10, denominator is equal to, see here, 1, 7, 10, 10. Next, next. Okay, this one is equal to transfer function numerator comma denominator. Okay, then I will write down display observe transfer function. Okay, after observation, what it must do? Hit the keyboard again. So type return when ready to return. Ready to return. Return means enter button. Okay. So this is display button. Then use the keyboard command. So keyboard. Okay. Then step this one, grid on. Okay. Then display observe step response. Observe step response, comma, type return to observe response parameter. Response parameters. ठीक है, response parameter. Then again I will say कीबोर्ड. यानी पहले आपने ट्रांसफर फंक्शन देखा, देखने के बाद एक बार इंटर और दबाया तो स्टेप रिस्पॉन्स कैलकुलेट करेगा. फिर आपको एक बार और इंटर प्रेस करना पड़ेगा तो आपको पैरामीटर्स दिखाएगा वो. ठीक है ना. तो उसका सिंटेक्स क्या है पैरामीटर का, देखिए. एस इज इक्वल टू स्टेप इनफो इन ब्रैकेट system1 sys1 this. Okay, so this is the complete response. Let us do it hands on this one. Okay, तो एक नया फाइल ले लेंगे. ओके, clear all CLC. Okay, n equal to 10, d equal to 1 7 10 10. Okay, then sys1 is equal to transfer function n comma d. Okay, then I will say display observe transfer function, comma, type return. Okay, type return when ready to return. Okay, this is, then say keyboard okay, then say step sys1 grid on. Okay, then say observe step response, observe step response, type return when type return. Okay, to observe to observe response parameters. Let us see display keyboard s equal to step info this para this para सेव कर दिया मैंने इससे. ओके, let us run this. Okay, so this is 10 upon s cube plus 7s square plus 10s plus 1. If I hit a return, okay, so I will type return. Okay, see the response. Okay, observe step response. Here it is a step response, then return. Okay, see the characteristics. See the characteristics here. Rise time, settling time, settling minimum, settling maximum, overshoot, undershoot, peak, and peak time. Okay, so this is how you get the system response characteristics. System response characteristics. Okay, So let us check the figure. Okay, so you can say system time 3 second, amplitude 1.12. Let us say here I want to write down. Okay, system time seconds 8.2, amplitude 1, steady state response. This is the overshoot. Overshoot is 1.12, maximum overshoot. Okay, rise time is, okay, at different point you can find out different information. Okay, let us say right, this is system dark blue. Okay, characteristic peak response. Okay, so peak response you got, characteristic settling time. Okay, so this is settling time. What is the settling time? 4.53 second. Again right click on this, characteristic rise time. What is rise time? 1.35 seconds. Again click on characteristic steady state. See the steady state. Final value was steady state and time is 9 seconds. Okay, so this is how you get the response. Okay, so what else we got here? Properties. Limits you can see, x limit, y limit, time second. This is options. Show settling time, minimum time within 2%. Show rise time 10 to 90%. Okay, so number of standard deviation for this place 1000. Okay, so statistical data you can get from the plot itself, from the plot itself. Okay, so let us move on to our PowerPoint presentation. Okay, so now let us move to one. Let us move to one LTI viewer. It is a pane. LTI viewer. LTI means linear time invariant. LTI. Okay, so how to invoke LTI viewer? Invoking LTI viewer. So in this commands are LTI view sys. Okay, it opens LTI viewer containing tape response of model sys, model SYS. Next command is LTI view sys1 sys2 sysn opens LTI viewer for models sys1 sys2 dash 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 sysn. Okay. Next is LTI view opens an empty LTI viewer for system analysis. Okay, so we have got last program was like this. N1 is equal to 10, isn't it? D1 is equal to 1 7 10 10 in the previous example. This one is transfer function N1 comma D1. Okay, so after that we have got LTI view this one okay. In this way you can get the LTI view. Let us see. Our program is straight away written, so no need to write it once again. Okay, just what I will do is I will in the command field, command window, CLC, clear it, LTI view sys1. Step response. Plot uses step response. You can find out impulse response of the same system. This is impulse response. Okay. You can further find out Bode-Nyquist singular pole zero plot also you can find out from the same system, same LTI viewer, linear system analyzer. Okay, so this is very helpful for your analysis, LTI viewer. Okay, so I will close this. Okay, okay. See, system is clear. One system is clear. Okay, system one is clear. Now we will, what we'll do, we'll add another system here. We will add another system here. What type of system we'll add, we'll see in the PPT first. Okay, so let us see. We will add a second system. Add a second system. Let us see. G2S, sorry, transfer function 2 is equal to CS divided by RS. This is equal to 4s plus 4 s square plus 2s plus 5. Okay, s square plus 2s plus 5. Okay, let us go to MATLAB command window. So n2 is equal to s 4s plus 4 is my numerator. So 4 space 4. Okay, denominator 2 is equal to square bracket. What was the denominator? S square plus 2s plus 5. 1 space 2 space 5. 1 space 2 space 5. Sys 2 is equal to transfer function n2 comma d2. Okay, transfer function n2 comma d2, then LTI view in bracket sys1 comma sys2. Okay, after that we'll write down s. What was our s is equal to sys info, step info sys1. So s1 is equal to step info sys2. Step info sys2. I will save this, then run the program. Let us see. Okay, let us see. Okay. Now what I will do is, in this system, see if I omit this. Okay, omit this step. Grade on system info n2 d2 system to transfer function n2 comma d2. Then I got step sys2. Step sys2. Okay, just save it and then I will run this program. So how beautifully this graph is there for comparison. This is for system 1. Okay, this is for system 2. Okay, so you can, if I want, suppose plot type impulse. These are impulse plots. Plot type impulse. I want characteristics of settling time. I want characteristics of settling time. Okay, see here, settling time is 3.54, settling time is 5.4, 5.4. So in this way you can find out. This is for system 1, this is for system 2. In this way you can find out the settling time. Okay, so this is the, let us take one more example for today. This will be our last example. Okay, let us erase all this. Let us erase all this. Okay, example, forward path transfer function of unity feedback system is gs equal to s plus 1 s square plus 2s plus 16. Obtain time response using step input. Time response using step input. Okay, here to also find out peak time, percentage overshoot, and settling time. Settling time using import option of LTI viewer. Import option of LTI viewer. Okay, okay, so how to do it? First of all, let us take new script file. Clear all CLC. Okay, now I want, this is what, N1 for open loop transfer gain is equal to 1 space 1 h plus 1. Okay, D1 is equal to s square plus 2s plus 16. That means 1 space 2 space 16. Okay, N2 for HS is 1 by 1. 1 by 1. Okay, so numerator is equal to 1, denominator is equal to 1. Unity feedback system. Okay, then what will be the answer? What will be the command? Which command? Feedback command. What will be the feedback command here? Okay, what will be the feedback command? So I will say n3 comma d3 is equal to feedback in bracket, okay, n1 comma d d2. Okay, so this is feedback command. Okay, so after that print says n3 comma d3. Okay, n3 comma d3. Okay, this is equal to transfer function. This is equal to transfer function. Okay, n3 comma d3. n3 comma d3. Okay, after that we will write down LTI view in brackets. Okay, save this. That means this is what unity feedback characteristic 1. Unity feedback characteristics 1. Okay, then what you want to find out? What you want to find out? Peak time, rise time, peak time. Okay, this is a step response, so you have to find out step response, peak time. Okay, and you want to find out percentage overshoot, that means peak response. Okay, settling time, peak time, settling time. So if you click on this, peak amplitude is 0.189. Okay, peak overshoot is 220 percentage. At peak time is 0.368. Let us see this one. System settling time is 3 seconds. So in this way all parameters you can find out easily. Okay, so see such a beautiful thing you can do with the MATLAB programming. Okay, so let us move to our PPT. So in this way you have solved some good example on rise time. Okay, so I will wrap it up for today itself. Okay, so thank you very much. Okay, so how to use Unacademy platform to unlock free plans. Okay, so go to Unacademy learning app, install it, go to daily interactive live classes, GATE ESE, select that, select the goal, GATE ESE. Okay, plus subscription, you can find out some courses where if you click on this, you can click on this. Okay, then you will be asked to find out invite code. Enter my code SSM10. Unlock it, then you will be able to watch this video for free or course for free. Okay, so like our YouTube channel, comment on it, subscribe it, hit the bell icon for further notification. Okay, use my code for discounts and offers, and registration to various combat and other competition. Okay, so join our Telegram channel also for latest update on upcoming videos. Okay, so with this I'll wrap it up for today. Okay, thank you very much. This is Sunil Manjani signing off for today. Okay, thanks a lot.